We are Science for Life. We are here to make the world a better place. We are the trusted ally of animal producers in Asia, Africa, and the Americas. We are here to create value with sustainable, efficient, and innovative products that transform challenges into effective solutions. Solutions for animal welfare, solutions for you. Smart and advanced products to take care of the productive development of animals. Natural alternatives for conscientious production and development. Functional additives to enhance productive performance. We are proud members of Illuma Alliance, a place where knowledge, technology, and innovation come together to forge a better world. Our innovation centers help us validate the safety, feasibility, utility, and sustainability of new concepts. Our international laboratory network allows us to provide ultra-precise and efficient solutions. Our pilot plants enable us to transform concepts into functional products. Our experimental farms offer precision in vivo utility testing. This is our ecosystem of skills, capabilities, and mindset. This is the ecosystem we make available to you in order to provide solutions for your animals and for a better world. We are Alura. Science for Life.
Good morning, everybody. Welcome to the Alura Looking Ahead webinar. This is the first webinar of our 4-series webinar on poultry food safety from farm to table. I am Cristina Mesa, and I have the privilege of serving as Global Marketing Manager for Alura. Today, it's my pleasure to be your host and moderator. Before we kick things off, I'd like to inform you that this session will be recorded and we'll have the Q&A session at the end of the presentation. You can post your questions at the chat box, and we'll do our best to address as many as possible. Joining me today is Dr. Lynn Walker. Dr. Walker is an assistant professor at the prestigious Department of Poultry Science at NC State University. She earned her PhD in food science and technology from University of Nebraska-Lincoln, as has a strong background in poultry science and pathogen detection. She has a board expertise in food safety, food processing, and storage with a proven track record of research and leadership in both academic and corporate settings. Dr. Walker is an active member of professional associations and has been recognized for her innovation and contributions to the food safety industry. I'll pass the mic to Dr. Walker. Dr. Walker, the stage is yours. Yeah, okay.
Can you all see my screen?
Yes, Dr. Walker.
Yes.
Cool. All right. Great. Good morning. Thank you for the introduction. Good morning, everyone. I'm very honored to be the first speaker of this webinar series, and I will give an overview of food safety and discuss why it is important to control food safety from farm to table. All right. Our poultry industry has been very diligent on salmonella control, and the incidence of salmonella infection in poultry populations has been steadily reduced over the years. As we can see from this chart, from breeder flocks to broilers to turkeys and layers, the flock incidence has been reduced gradually. However, when you look at the orange line, which represents the number of human salmonellosis, it did not drop steadily as the incidence rate in poultry population. These two graphs compare the prevalence of salmonella in raw poultry products and the salmonellosis associated with chicken. In the chart on the left, different color lines represent different poultry products, including whole carcasses, parts, ground chicken, and breasts. Overall, contamination rates has decreased over the past 2 decades for most type of the poultry products. However, the number of outbreaks associated with chicken products was not reduced, but actually increased a little bit from 2000 to 2018. The previous chart was for all the salmonella species. Now let's dive into the specific serotypes to give a closer look. Despite the peak of tafamurium incidence rate in poultry products in 2010 and 12, salmonellosis caused by tafamurium has been steadily decreasing from 2001 to 2018. And for Heidelberg, the trend of prevalence and illness matched pretty well. Although the overall salmonella prevalence was reduced in the past 2 decades, the prevalence of enteritis didn't follow the same trend, but instead increased. So the associated salmonellosis didn't drop, but slightly increased over the years. We have started to see more and more infantis in the past 10 years, although this serotype was not so common before. Accordingly, the associated salmonellosis caused by infantis is increasing as well. However, compared to tafamurium and enteritis, infantis is not as virulent, so the illness rate is not as bad as the other 2 serotypes. Since 1996, USDA FSIS first established the pathogen reduction performance standards for poultry products. The foodborne illness caused by these pathogens have now been reduced as expected. In 2010, the federal government set a goal to cut the nation's incidence rate by 25% over a decade, but the goal has not been achieved. The agency start to think, where is the missing part that causes the illness still this high? So instead of regulating the prevalence of salmonella in poultry products alone, the agency start to look into salmonella prevalence, population, and serotypes during the production and the processing, so the risk of salmonellosis can be appropriately predicted and reduced. A year ago, FSIS proposed the salmonella framework, which is a 3-pronged approach to control salmonella. The first component requiring incoming flocks be tested for salmonella before entering the processing plant. The goal of this component is to incentivize use of pre-harvest interventions that reduce the level of incoming salmonella contamination or mitigate the risk of a particular serotypes entering the establishment. Since USDA doesn't have the jurisdiction over live production, this component has received a lot of questioning and debate. Since the framework is still under public comment period, we don't know exactly what it will turn out until the end. In the second component, FSIS is requiring a sampling at Howraham, in addition to the post-chill sampling, which they are doing right now. FSIS is also considering requiring that establishment using a standardized statistical approach to control the process. At last, FSIS is conducting some risk assessments and will likely claim certain serotypes or subtypes of salmonella as adulterants in poultry products. This final product standard would promote salmonella reduction by establishments and incentivize upstream practices that reduce salmonella, including on-farm and transportation practices. The salmonella framework made a huge splash in the industry, and as it demands a lot of new changes in the way how we raise the birds and process them. FIS keeps extending the public comment period, and we know that the industry, including organizations that are representing the poultry industry, such as NCC and NTF, are actively communicating with FIS to make the framework more feasible for the industry to comply with. From my interaction with the industry group, here are some latest updates that I can share with you. But please keep in mind, none of these are finalized. Regarding the first component, FIS may not mandate the on-farm testing, but the establishment still needs to have a way to know their incoming load. For the third component, there are 3 serotypes and subtypes that possibly claimed as adulterants, and they are enteritis, tefimurium, and a monophasic variant of tefimurium. Another good news for some of you who are retiring in the next 2 years is that you don't need to worry about the framework, as it may not be active until 2027. Through my education and professional career as a food safety scientist, I have been trained to be a strong believer that food safety needs to be controlled from farm to table. Just as the picture showing here, food safety cannot be achieved with any of the pillars missing. When we recall the milestone event for food safety, Jack-in-the-Box outbreaks, is a very good example illustrating how foodborne illness happens. The meat itself was adulterated with E. coli 0157. However, if the meat was not temperature abused during transportation and was not undercooked, the tragedy could probably have not happened, or at least not as bad as that over 700 people were sick and 4 little children lost their lives. So what I'm trying to say here is that we have to review food safety in a systematic way. To ensure food safety, multiple hurdles or interventions are applied throughout the whole chain of food production. In the next few slides, I'll briefly mention the interventions that have been used in the processing and lab production. I believe we will have Dr. Halfaker, Dr. Sanchez, and Dr. Mori. They will talk more in much more details about the interventions at pre-harvest and in processing plants in this webinar series later on. So I will start with the processing and discuss why interventions in processing alone cannot ensure food safety. This is a brief flow chart for poultry processing. And if you have ever gone to a processing plant, you will notice that lots of interventions, especially antimicrobials, are applied at almost every step after scalding. Antimicrobials are commonly used interventions in processing plant. PAA, quat, chlorine, acidified sodium chloride, and organic acids are the most common ones. Bacteriophage have showed good reduction in salmonella and are used in by some companies. Electrolyzed water in combination with antimicrobials has a synergistic effect to reduce pathogens. Many ready-to-eat products, such as lunch meat, are high pressure processed, as this non-thermal technology has many advantages as compared to the conventional thermal processing. Ionizing radiation, such as E-beam, can effectively eliminate the bacteria in the meat, but there are some consumer acceptance concerns. So each of these interventions, they all have their own pros and cons. They each can only do so much. Their efficacy is highly dependent on the initial load of bacteria. I will use this study's results to show you some facts. The study was established to develop a predictive model for reduction and cross-contamination of salmonella on chicken in chilling process. This figure describes the post-chill incidence of initial contamination level and the pre-chill incidence at a fixed chlorine concentration of 50 ppm. The post-chill incidence of salmonella was significantly reduced at the initial contamination level, as the initial contamination level and the pre-chill incidence decreased. And the post-chill incidence was more sensitive to the initial contamination level. Post-chill incidence was more responsive to the initial contamination level than the chlorine concentration. So basically, it means, by increasing your chlorine or your antimicrobial concentration, you might get a better results by reducing your initial coming load. So similarly, post-chill incidence was more responsive to the pre-chill incidence than to the chlorine concentration. This study tells us the initial load of salmonella plays a major role on the prevalence of salmonella in the final poultry products. Normally, when we see we see very low prevalence of salmonella right after chilling, but the percentage of positives start to creep up as the processing moves further. One of the reasons is cross-contamination. In further processing, there are multiple touch points. Many manual handling involve the personnel. Many ingredients are mixed to make the final products. And if any of the ingredients is contaminated, the final product is likely to be. Some kind of heating process is often used in the further processed products. The heat could promote pathogen growth. And if cooking and chilling are not properly controlled, so comminuted products has the highest food safety risk compared to the other type of products because of skin, neck, and bones involved. Therefore, mechanically separated meat are normally sent for lethality treatments such as cooking. So current sampling methods in the processing plant and many interventions are only targeted for the surface salmonella. What about the internalized ones? This picture shows the localization of salmonella in tissues of experimentally infected chickens. The picture on the left shows salmonella hide in these skin follicles, and the other one shows salmonella hide in the bone marrow of chicken. So there are multiple studies on salmonella harborage in skins and bones. Although the incidence in bones is much lower than skins, the impact should not be underestimated due to the elevated temperature during this mechanical separation process and the potential cross-contamination within the machine. So because of the facts we discussed, it is critical to have on-farm interventions in place to reduce the incoming load of salmonella and to reduce the incidence of internalized salmonella, which will now be killed by antimicrobials in the processing plant. Vaccination could be one of the most effective interventions against salmonella in poultry, although the commercial vaccines for Campylobacter are still under development. So needless to say, the importance of biosecurity, cleaning, and disinfection. Some feed additives and water treatments have shown certain reduction of salmonella and Campylobacter. Litter quality, which plays a key role in poultry health, should never be neglected. Again, we go back to our previous slide. Multi-hurdle to control these pathogens from farm to table is the key. Speaking of table, we cannot overlook the downstream where the products are leaving processing plant and end up on the consumer's plates. So this is a typical profile of temperature changes in the cold supply chain from rural production to consumer's table. We can see lots of temperature variations along the chain and multiple events of temperature going above this critical limit. The temperature abuse can cause bacterial growth to a certain threshold that the food is no longer safe. Food safety also highly relies on how consumers or cooks in the catering service deal with the food. Do they have good hygiene practices? Is there any temperature abuse before cooking, such as thawing the meat at room temperature for hours? Do they follow the cooking instructions and cook the meat properly? How do they deal with the leftover food? Do they leave it at room temperature for hours or even overnight? In a statistical survey observing 88 poultry-borne outbreaks, it was found that the highest percentage of contributory factor to the illnesses were actually related to the handling of the product at home. Improper refrigeration was involved in 48% of the outbreaks. Preparing food 1 or more days before serving was involved in 34% of the outbreaks, and the inadequate cooking was involved in 27%. Here's a study conducted by Dr. Ben Chapman's team in our consumer science department at NC State. They studied consumers' behavior on food safety. The consumers were asked to wear some kind of special glasses that can track what they read on a poultry product label. So the places they look the most are marked as red color, and then yellow, then green. So here we see that they read a lot in the ingredients. Probably they were trying to find if there were any undesirable food additives in there. And they did look at the cooking instruction. However, where it says raw, do not microwave over there, and it will barely looked. This is pretty scary because we know lots of consumers are confused of ready-to-eat food and non-ready-to-eat food because those foods, they often look alike when they are frozen. And the consumers might throw a non-ready-to-eat food in microwave for a couple of minutes just to warm it up. I think that's probably why FSIS is regulating the non-ready-to-eat meat stuffed chicken for no more than 1 CFU per gram of salmonella. And Dr. Chapman's team also found that there are lots of poultry washer, although studies have shown that washing poultry can only cause more food safety risk because of the cross-contamination. 26% of these participants that washed the poultry, raw poultry, they transferred bacteria from that raw poultry to their ready-to-eat salad ladders. And out of the participants who washed their raw poultry, 60% has bacteria in the sink after washing or rinsing the poultry. Even more concerning is that 14% still had the bacteria in their sink after they attempted to clean the sink. So what can our poultry industry do? This is not a criticism, but from my own experience, I think poultry industry is a very conservative group, just like all the other agricultural commodity groups. A lot of times we are not willing to take changes as long as the current practice still works. We are hesitant to let the consumers know about the risk, although you would argue that they are all on the label. But remember the slides about consumer reading labels? So what if we are more vocal? What if we are more proactive? What if we lead the changes on salmonella control rather than being cornered by the regulatory agency to tell us what kind of product standard we should have? These are our products, and we should take the ownership of it. We should know better than anybody else on what kind of salmonella are in these products and how much of these pathogens are there. Again, food safety is from farm to table. The responsibility to reduce foodborne illness should now be solely land on the shoulders of processing plants. Effective interventions at farm levels are greatly needed. So are the education of consumers on food safety. And here are some of the references I use in my presentations. And if you are interested, feel free to dive into those studies. And that's all for my presentation. Any questions?
Thank you, Dr. Walker, for your enlightening presentation. We've been receiving some excellent questions in the chat, so we're going to start with this one.
Okay.
Hi. What method by Dr. Chapman was used to show those different colors in the instruction label?
So they use a special goggle, to put on the consumer. So somehow that goggle, I don't know exactly the technology behind it, but they track where the consumer look. So if they look at a certain spot, and then that's where, you see the red color. So the green color, it means they just looked very briefly. And if there's no color at all, it means they didn't even look. And they have a whole panel of consumers being tested in this just to see, their behavior or their habit of reading a label.
Thank you, Dr. Walker. We have another one here. You mentioned that salmonella was reduced in poultry productions in 2017 and 2018, but human infection from poultry was not reduced. Can you provide your thoughts on why the human infections did not follow the same trend?
I think, well, first of all, as I mentioned in the last few slides, consumers play a very big role on it. because once the product leave the processing plant, there's still a lot of variations unknowns, like how, if any temperature abuse happened downstream, including transportation at the grocery store. So any of those and how consumer deal with their food, the cross-contamination, those can cause the foodborne illness. Another thing is in the first few slides, when I show you the salmonellosis by serotypes. So we can see actually Salmonella enteritidis, it wasn't really reduced. Salmonella enteritidis, which we know is a very virulent serotype of Salmonella. So that is the prevalence is still going up, and the foodborne illness caused by enteritidis is still going up. So there are multiple factors that contributing to this not reduced salmonellosis. But I really think consumers, they do play a very important role in this.
Thank you, Dr. Walker. We have another one here. Production system nowadays are leaning towards free range and organic farming, etc. How has this affected the prevalence of Salmonella?
So actually, I'm conducting a literature review on all those different alternative housing systems on food safety. So based on what I have done so far through this literature research, we see this very controversial results. Some of studies, they said organic or this free range production system, the Salmonella rate or Campylobacter rate is greatly reduced because because they have fewer birds, the density is reduced, and they tend to have better gut health. But there are some other studies show that actually those numbers, they were either not affected at all or they actually increased. So there's really no defined conclusion of whether those alternative housing product make the Salmonella or Campylobacter really reduced or not. But we do know that with this outdoor access, we do expose the flock to much more risk to this biological hazard, because Salmonella, Campylobacter, those are all environmentally naturally exist in the soil, right, in the wildlife, in those wildlife birds, and it's in the insects. So with the access to outdoor to all these components, it just naturally they probably are exposed to Salmonella and Campylobacter more easily. But again, that doesn't necessarily mean that the birds itself is going to have more Salmonella and Campylobacter, because I'm a true believer of a healthy gut. Like if the birds have a really good gut system, and then they will develop their way to against Salmonella and Campylobacter. So again, I think so far we have only done this for so many years, and there's still a lot of unknowns and studies that we could explore.
Thank you. We have another one. In your opinion, what is the best approach to control Salmonella currently?
I think what has been doing in the processing plant has been great, and I know a lot of the processing plants, they are also actively looking for some other alternative interventions. So they are really trying their best to reduce Salmonella and Campylobacter. And from on the farm level, we started to look a lot into what we can do at the farm level. And again, as I said, we haven't, because of regulation pressure, because we used to now have this pressure from USDA. So we that's kind of the loose part where I think there's a lot of things we can do, especially since I mentioned those internalized Salmonella, because on another roundtable I participated, we have with some other industry people, they highly suspect that there are some salmonella they were just internalized in it, and it's just it's there, just a systematic salmonella. So then in that case, it's really how you raise the bird. That's where you could control salmonella, because in the processing plant, all they can do is apply with those those things from the surface, or for the further processing. Those they can do a lot, but again, for the raw poultry products, basically the interventions is very limited.
Thank you again. We have another question here. How about climate change? What is your opinion on its effect on salmonella or overall foodborne pathogen prevalence?
Do you mean the lighting change?
Climate change.
Climate change. Sorry. Climate change. So definitely, seasonality, that is a really big role. And whenever we sample salmonella, we see that we tend to have more salmonella in the warmer seasons than in the colder seasons. That's just natural. And climate, for sure. Like the one we raised the birds in North Carolina or Georgia or even down the south, compared to the ones from Minnesota or Iowa, I would say the climate definitely would play a role in it. There's a lot of, not just the salmonella itself, a lot of the other disease, is also regional, which is likely, due to the climate or due to a lot of other reasons. But the climate, it definitely can be a very important factor.
Okay, we also have one raised hand. Abiola, I'm gonna unmute you so you can ask your question. Abiola, do you have a question? Okay, I'm gonna move forward with the questions that we have on the chat. How does the incidence of salmonellosis in human from poultry compare to the rate of infection from other food sources?
Can you repeat the question again?
How does the incidence of salmonellosis in human from poultry compare to the rate of infection from other food sources?
So yeah, I didn't show that chart. Actually, salmonella is not just in poultry. Even though poultry products and egg products overall, they do, I believe they contain like about maybe 30%, 29%, something like that. But there are also a lot of salmonellosis are caused by the other type of food products, especially actually the fresh produce itself. They just because there's no lethality treatment to those fresh produce, and they have very limited options for interventions. So actually those they have a lot more salmonella as well. Yeah, salmonella is not just for our poultry. Yeah, but they do, but poultry products, they play a really big role in salmonellosis.
Okay, we have another question here. Which pathogen species serotypes are of most concern for humans?
So as we mentioned, those enteritis, Typhimurium, and so another one of the monophasic variant of Typhimurium is likely to be claimed as adulterant because it's has a lot of foodborne outbreaks were associated with that specific subtype of salmonella. But just overall, when we look at salmonella outbreaks, Heidelberg and Newport, and let me see what else. There are 5 of them. So I've named 4. So all those actually they are pretty common causes of human salmonellosis.
We have another question. Is there a consumer education program that could help us reduce incidents of human infection being launched to coincide with the new FIS regulatory landscape? I'm going to repeat that.
Yeah, I got it. Yeah. So yeah, talking about the consumer part, I feel like, you know, not just the industry needs to do it. It's mainly from us, like from academia as extension service. So that's where we should focus on to educate our consumers. I know a lot of I'm in the poultry science, so I work more with the industry. But like Dr. Ben Chapman from the consumer science, they work more with the consumer group. So I'm pretty sure they are doing a lot of educations or some other activities, you know, try to improve the awareness of food safety. But a lot of times it really just takes it takes a lot of effort, especially you know, like we as a company, like if we could just be more vocal about the risk, because sometimes we feel like, oh, we don't really want to talk about it, it's supposed to be safe. Or you can say, okay, it's already labeled on the product, it says it's raw, it's not ready to eat, and they decided to cook it in a proper way. But again, you know, consumers, they are actually pretty stubborn group. Like there's a study show the way to really change the consumers practice in food safety is is not through how much, you know, like advertisement you do to them or the other way, but it's really the foodborne illness that they had. It sounds really sad that but again, it just tells us how hard it is, you know, to change their mind. But we just have to be really diligent on doing this and being very consistent, and you know, just let them know this is a raw chicken. And I feel like me as an extension specialist, you know, I do have a role to I'm one of the ones to be blamed for not you know, pushing this forward. But I'm pretty sure we are working with the consumer groups. I know the effort is going on there. It probably will happen along with FIS, you know, the regulations. But again, FIS, they are focusing on the industry because that's where they regulate. But USDA, they do have the consumer sessions, and they are doing their due diligence on their end as well.
Thank you, doctor. We have another one here. Why are some serotypes like S. infantis and enterovitis increasing in prevalence?
That's a very good question. Infantis is, you know, is kind of new in the last 2 decades. So, well, my personal belief, I feel like salmonella is always going to be there. It's just a matter of who are they, like what serotype of salmonella. And we are not going to eliminate salmonella in poultry. But, you know, by this pressure from the regulations, let's see if in the next few years they decided to claim those 3 serotypes or subtypes of salmonella as adulterants. Then what's going to happen is we developed a lot of vaccines, right? For those claimed adulterants, and then those numbers is going to be reduced, like some enteritis. But what happened is when you reduced those serotypes, what happened is going to be, you know, the other serotypes, they are going to take over, to take the niche. Some of salmonella is going to be there. And so this is going to be a very constant chasing tails game. You know, every few years, you always have to monitor what are the prevalent serotypes of salmonella in your products or on the farm level, and then keep monitoring it. And then eventually, you know, maybe in 10 years later, we are going to change the regulation to the other adulterants, and we have to change our vaccination program. So it just I think the reduce of those and the increase of infanticide, that's just an example, you know, because when we have an outbreak, we focus on those stereotypes and then we knock them down, we reduce them. But then again, like some other stereotype, like infanticide, they are just going to take over.
Okay,
but the good thing is that at least infanticide is not as virulent.
Okay, we have one last question here. Here we go. Are there other segments Are there other segments of the food industry also in the scope of FSIS for change increased regulation to try to reduce human exposure?
Sorry, can you repeat it again?
Are there other segments of the food industry also in the scope of FSIS for change increased regulation to try to reduce human exposure?
To reduce human exposure. I know the NCC, National Chicken Council, and the NTF, National Turkey Federations, and even NAMI, the North America Meat Institute, they are the very active industry groups. They are very advocate for the industry, and they are working with the regulatory agencies, you know, on this part. And on the consumer part, again, I'm more kind of my role is more working with the industry. I'm not the consumer side, so I'm not very familiar with what the other consumer side of group is doing.
Okay, Dr. Walker, thank you so much. Once again, a big thank you for sharing your invaluable insights with us today. We'd also like to extend our gratitude to all the attendees for joining us in this webinar and to our dedicated colleagues behind the scenes who work really hard to make this event possible. Remember, this is just the beginning of our 4-part series. Our next session is scheduled for December 7th at 9 a.m. Eastern Time. Dr. Charles Hoffaker will be enlightening us with our pre-harvest pathogen control. We look forward to having you join us again. Wishing you all a wonderful day. Thank you very much and goodbye for now. Thank you, Dr. Walker.
Thank you. Bye.